I'm Jabadass Dinagaran, working as a physics teacher in Madras Christian College Higher Secondary School, Chennai. In this video, we are going to study about the De Morgan's theorem. In your 12th standard practicals, we have the De Morgan's theorem. So, you are going to verify the De Morgan's theorem using your IC trainers. So, here I have a board where we have connected the IC. So, if you see the De Morgan's first theorem, a plus b the whole complement is equal to a complement dot b complement. And the second theorem, a dot b the whole complement is equal to a complement plus b complement. So I am going to verify both the theorems using this IC trainers, which is already built in, and I have to give the input, and I am going to verify the left hand side of this theorem with that of the right hand side. So first I am going to verify the left hand side. So for that I am going to connect two inputs. A is the input, give it to the A of the circuit. This is for the first theorem, and this is the input B. So what is the gate? It's an OR gate, A and B. So the output is A plus B, and followed by a NOT, that is we have the complement A plus B the whole complement. Complement means we have to take NOT. So A plus B the whole complement, that will be the output. So you connect the output here. So I have given the inputs A and B, and I am getting the output. So just switch on the board. So I have given the input low and low, that means 0 and 0. The output is 1. So you have given 0 and 0. The output is 1. And the second possible input is 0 and 1. So B is 1, A is 0. Output is 0. You see there is no light is glowing. So it is 0. And the third possible input is 1 and 0. The output is 0. You can see there is no light is on in your output. A, light is there, so 1. B, there is no light, 0. Output is also no light is there, so 0. And the fourth possible inputs are 1 and 1. A is also 1, B is also 1. So output is 0. So we have 1 and 1, we have 0. So we have just verified the left hand side of the theorem, A plus B the whole complement. We are getting for 0 and 0 it is 1, 0 and 1, 0, 1 and 0 it is 0, 1 and 1 is 0. Now we have to do the right hand side part. Switch off the board, then connect it to the second half of the circuit, output to that of A complement dot B complement, and inputs A to that of A and B to that of B. So this is the right hand side of the theorem. So we are getting A complement and B complement as our output, and you are going to give it to an AND gate. So AND gate will do A complement dot B complement. It will give the product. That is output. I am going to on the board. You are going to give the input 0 and 0. The output is 1. So 0 and 0, the output is 1. And secondly, 0 and 1, the output is 0. So 0 and 1, output is 0. And third option is 1 and 0. A is 1, B is 0. Output is 0. So 1 and 0 is also 0. And the fourth possible inputs are A is 1, B is also 1, output is 0. So 1 and 1, output is 0. So from your tabular column, you are able to understand the left hand side of the equation is equal to the right hand side of the equation. So De Morgan's first theorem, what it shows, A plus B the whole complement is equal to A complement dot B complement. So when a plus b the whole complement shows 1, a plus a complement dot b complement is also 1. So they will show similar readings. So that means the LHS is equal to the RHS. So now we have to do the calculation for the first theorem. A plus b the whole complement is equal to a complement dot b complement. So first the inputs are 0 and 0. So 0 plus 0, you take the whole complement, that is 0 complement is 1. So 0 plus 0 is 0, the complement of 0 is 1. Similarly, the right hand side of the equation, both the inputs are 0 and 0. So a complement, 0 complement is 1, dot 0 complement, that is also 1. So 1 dot 1 is 1. So left hand side and the right hand side, they have the same value. Similarly, you do it for 0 and 1, 1 and 0, 1 and 1. So again you have to verify the second theorem, De Morgan's second theorem. A dot b the whole complement is equal to a complement plus b complement. So for that we have again taken the IC trainer, already this is an inbuilt circuit. So you connect A to that of A, B to that of B, and your Y to that of your output. That is A dot B the whole complement. Now switch on the board and give the possible input 0 and 0. The output is 1. So 0 and 0, the output is 1. And second possible input is 0 and 1. The output is 1. So 0 and 1, output is 1. You can see the light is glowing. And third possible input is 1 and 0. Then also it is 1. And the fourth possible input is 1 and 1, 1 and 1, output is 0. So 1 and 1, A is 1, B is 1, output is 0. You can see there is no light is glowing. So you have done the left hand side of this equation, A dot B the whole complement. Now I have to verify with that of A complement with B complement, that is the right hand side of the equation. For that, do the connection again. Connect A to that of A, B to that of B, and Y to that of the output. That is the right hand side part of this equation. This is also built up with IC trainers. It's a built-in board. Now switch on the board. You are given 0 and 0. A is 0, B is also 0. You can see the output is glowing. So output is 1. So 0 and 0, output is 1. And the second possible input is 0 and 1. So that is 1. So 0 and 1, we have the output is 1. Light is glowing. Again, the third possible input is 1 and 0. That is also 1. Output is 1. And the fourth possible input is 1 and 1. Output is 0. You can see there is no light is glowing in the output. So 1 and 1 is 0. So here also you can see the LHS of the equation is equal to the RHS of the equation. So the second theorem is also verified. And you have to do the similar calculation as I told you earlier for the first theorem. And finally, don't forget to write the result. The De Morgan's theorem is verified. Very simple experiment. Don't miss out.